I will show you two demos. One is for small data set and one is for large data set. So two demos of remote visualization on CEDA. The first data set is a simulation of deep impact by an asteroid. And this is actually a fairly large simulation. I only take a subset, so a low resolution subset of the simulation. And on CEDA, you can find it in the following directory. This directory is open to everybody. All of you should be able to read it. And there is 12 gigabytes of data in there in total. But in fact, there are many time steps, and each time step is much, much smaller. So to be able to read this data set, we can actually do it in serial on a single processor on CEDA. Let me give you a demonstration. Let me open my shell. I'm running Tmax on my MacBook, on my laptop, and I want to split it into left and right panel. So I'm going to say Control B and then I guess %. So here on the left, what I'm going to do is I'm going to connect to CEDA cluster, SSH, then your username at ceda.computecanada.ca. So here now I'm logged into CEDA. On CEDA, I cannot actually start a job from the home directory. To start a job, you need to cd to some other file system, for example, to Scratch. So here I'm in Scratch, and then I'm going to submit a job asking for 1 CPU and then maximum runtime 30 minutes. Interactive job, so I'm going to submit it with Salog. And as you can see here, I get a problem. So as I mentioned, you need to specify if you have multiple allocations, you need to specify which allocation you're going to use with the -- account flag. So I'm going to say dev, this is my allocation. And of course, when you try this demo, when you try this on CEDA, please use your own allocation. So here we go. It's waiting for resource configuration. The job was started on node CEDA 676. Now I can actually start a ParaView server. So before I can do that, I need to load the ParaView module. So module load ParaView off-screen 5.5.2. And you may notice that this is an older version of ParaView. It takes some time to configure and compile ParaView. We actually don't have the latest version. When you run in client-server mode in ParaView, you have to use the same major version of the client on your computer. So that means that if I want to connect to ParaView 5.5 on the cluster, I need to use ParaView 5.5 on my computer. I'm going to type PV server, use off-screen rendering, like that. And this will start the ParaView server. So you see, waiting for an incoming connection on port 1111 on this node 767 of CEDA. So now I need to organize SSH port forwarding. Let me paste this into my other pane on the right. On my computer, I'm going to say SSH browsermof at ceda.computecanada.ca, and then -L will organize port forwarding. So I'm connecting this port 111 on my computer to this port 111 on the compute node 767 on CEDA. So let me do this. Now I'm going to start ParaView 5.5. And here it is. Let me actually resize it slightly so you can see the terminal right here where it says accepting connections. Notice what happens here when I connect from the client. So here in the client, I'm going to go to this button that says connect. And then here already set up the connection. So you can actually, if you want to set up a new connection, you can simply say add server. And then when you add the connection, you basically say server type client server, host is localhost, and the port is 11111. So this is the local port that is connected to the similar named remote port on the compute node on CEDA. All right, so what I'm going to do now, I'm going to click on this connection to localhost, and I'm going to say connect, and notice what happens here where it says accepting connections. So when I do this, it says client connected, and now I establish the client server connection. So let me go to ParaView, and then I will resize it. Now if I go to file open, it will actually give me access to the CEDA file system, right? So now I'm looking at my remote Scratch directory because this is where I started the ParaView server on CEDA. And I want to navigate to the directory on the slide. So let me just copy this. So I want to navigate to this guy. I will select the directory 6003910, and there's unfortunately, a lot of scrolling involved. So let me just find it. And here it is. And then here I go into RouseMoff, IEEE Viz 2018, this one. And then 460 by 280 by 240. And then here I have a number of time steps. And then I'm going to pick one of them. For example, let's pick this guy. So I'm going to say OK. And then make sure you load all hydrodynamical variables. So you have the boxes checked here. And then I'm going to say apply. And here it's loading my data set. So you see it's taking a few seconds, but this data set is not particularly large. So in fact, let me go to this directory where the data set is stored. And then let me do ls-l. You'll see that each data set is of order of 200, 300, 400, maybe 500 megabytes. So it's several hundred megabytes. So it's not very large. Each time step is a few hundred megabytes. And that means I can actually load it into ParaView server running with 3.5 gigabytes of memory. That's how much memory I asked when I submitted my job. So here it loaded, took only a few seconds to load. Looking at the outer surface, let me call it by one of these variables. For example, I'm going to select density. And as you can see, this is a three-dimensional data set. At the bottom, we have water, that is higher density, and at the top we have air, a lower density, and it makes sense. Let me switch to a contour view. I'm going to click on the contour filter, and I'm going to build isosurfaces of constant density. So where it says contour by, I'm going to select row density, and then let me try to enter a value 0.002, and then I hit enter. I say apply. So here all data processing is being done by the remote ParaView server running on Cedar inside my interactive job on a compute node. Let me also visualize the original data set like that. And then let me make the original data set semi-transparent. So if I go down to opacity, let's just reduce the opacity a lot. And as you can see now, while looking at this impact, right? So the shock wave or water from the impact is going into the air. And as you can see, when I try to rotate it, it takes maybe 5 or 10 seconds, maybe 5 seconds to refresh a picture. And this is because we are processing a fairly large data set and we're doing it remotely. Now I will apply a slice filter, so right here, to the original data set. And then the slice, I want to do it in the XY plane. So here in the properties of the slice, I'm going to say that it's perpendicular to the Z axis. So the normal vector is 001, like that. And then it's going to slice through the middle of the data set. So let me hit apply. And now let me color the slice by another variable, which is called TEV. And I suspect this is the total energy, although I'm not 100% sure. So let me color by that. And then let me actually change the color map. So right now we're using two color maps, and they are the same for displaying density and for displaying the total energy. So for total energy in the slice, let me switch to a different color map. I'm going to go to Edit Color Map, and it brings this dialog. And then here, I'm just going to select a different color map for the total energy. So let's just select something that is more monochromatic, like this one, for example. So I'm going to say Apply. Let me close this window and then close this guy. So as you can see here, we have the path of the asteroid in the air, and then we have the shock wave or the water ejected from the surface of the ocean. This dataset is something like 500 megabytes large, and you can actually visualize it interactively on a single core on Cedar. And if you want to save this picture, you simply go to File, Save Screenshot on my laptop, and then you can simply save the screenshot, for example, here. And I'm going to say Impact is going to save it as a PNG file. And I said, OK, just accept the default values. And here we go, we just saved the image.